Number 23 is about sand falling off a conveyor belt into a pile, which makes this conical shape. It's falling off at a rate of 10 cubic feet per minute. And what we know about the pile is that its diameter is 3 times its height. So they want to know at what rate is the height of the pile changing when the pile is 15 feet high. Okay, we know the rate of change of the volume, the amount of sand that's being added, is 10 cubic feet per minute. So we write our volume formula for the equation of a cone. It's going to be 1/3 pi r squared times the height. And again, we don't, not again, because you might not have watched the other video. We don't want the r and the h in this case, because if we take the derivative as is, the v would create a dv dt, the r would create a dr dt, and the h would create a dh dt. That's too many rates. We know that dv dt, we know what that is. We're looking for dh dt. We can't have a dr dt. Okay, we don't want to have that. So what happens is we can't really have r in our equation. We have to rewrite it so that we can substitute in for r and express our volume all in terms of h. So we're going to go ahead and do that. Get rid of this stuff. So my goal right now, before I differentiate, is to find the derivative, to find the volume in terms of h, since we have dh dt. So I'm going to write an equation that relates the h and the r. So since they said the diameter is 3 h's, right, this here, I should probably just call this diameter and be a little better. And the height there, they're saying that the diameter, they tell us, is approximately 3 times the length of the altitude. So I can write this little equation here. Now we need radius to be related to height, so a diameter is 2 radii. And then since I want to remove r out of my volume equation, I solve this for r. So now I can make a substitution here for r in my volume equation. So I've got 1/3 pi 3/2 h squared times h. So I substituted in for r, and now I want to simplify this before I differentiate. So I've got 9/4 times h. Further simplifying, the 1/3 times the 9/4, 3/4 pi h cubed. That's the volume formula for this particular cone. So now I want to differentiate that with respect to time. 3/4 pi is just a coefficient. So the 3 comes, I'm doing power rule here. H is my variable. So the 3 comes down and multiplies by the 3/4 to give me 9/4 pi. Recopy the base, the variable, h, reduce the power by 1, times the derivative of h with respect to time. So remember that now there's 3 variables. This represents the rate of change of the volume, this represents the rate of change of the height, and this represents the height. So we need to plug in all but one of those so we can solve for the other one. Let me get rid of some of these. So we know dv dt is 10 cubic feet per minute. They said when h is 15 feet, find dh dt, find the rate at which the height is changing. So I am going to have my 10 cubic feet over here. Can't wait till I get my Apple Pencil. I'll write much more neatly. We got to square the 15 and then multiply it by 9/4. So that's 225 times the 9/4. Getting 506.25. I like fractions, so I'm gonna leave it in fraction form. So 15 squared to 225 times the 9 is 2025. Divided by 4. Let's see if that reduces. I'm going to have my esteemed colleague, Zach Mangold, reduce that fraction for me while I finish this off. 2025 divided by 4. Can you reduce that? See if he knows. No. All right, good. So then it's feet squared, by the way, because I squared the feet. So when I divide both sides, I've got 10 times really the reciprocal fraction.
It's 526 and a quarter.
Okay, thank you. Yep, I'll leave it as a fraction. And that pi is in the denominator. And then it's feet cubed divided by feet squared, so it's going to be feet per minute. So then it's going to be 40 over 20, 2025 pi. Remember that pi is in the denominator. Finito.